Now I will discuss electric field due to a uniformly surface charged disk. Electric field due to a electric field due to a uniformly surface charged disk. Surface charged disk. A point P on the axis of the disk. On the axis of the disk that I need to discuss with you. Electric field due to a uniformly surface charged disk, a point P on the axis of the disk. So let us assume a disk. The disk of radius capital R. Disk of radius capital R. Let P be the point. P be the point. At this point, we need to calculate electric field. At a distance x from the center of the disk. From the center of the disk. Now this is the disk, right? So disk have elemental charge, total charge Q, elemental charge dq, elemental charge dq. So disk having elemental charge dq, dy is the width of the elemental ring. Dy is the width of the elemental ring, and y is the radius of the elemental ring. That indicates inside a disk a ring is present. So from here to we need to calculate electric field at a distance smaller. So elemental ring to a point P. Y is the radius of the elemental ring. Now we need to calculate electric field at a point on the axis. So dE we need to calculate. So as we know that electric field due to a point on the axis of the elemental ring. Electric field due to a point on the axis of elemental ring. E is equals to kqx by x square plus r square whole to the power of 3 by 2. Already as we discussed in the last video, E is equals to kqx by x square plus r square whole power 3 by 2. But the thing is here, r is the radius of the ring there. But here elemental ring radius is y. So now the r is replaced by y. So now dE is equals to k dqx by x square plus y square whole to the power of 3 by 2. This is a general formula of electric field due to a point on the axis, but elemental ring radius is y. So dE is equals to k dqx by x square plus y square whole power 3 by 2. So now dE is equals to k dqx by x square plus y square whole power 3 by 2. So our aim is to calculate dE. So first of all, this is electric field due to uniformly surface charged disk. The surface charge density sigma is equals to dq by ds. So dq is equals to sigma ds. But here ds is surface area. Surface area is length of the elemental ring into width of the length is 2 pi y, width is dy. So ds is 2 pi y dy. So now dq is equals to sigma into 2 pi y dy. This is dq. So this is equation number 1. This is equation number 2. From 1 and 2. From 1 and 2. So dE is equals to kx into dq value sigma 2 pi y dy by x square plus y square whole to the power of 3 by 2. So now dE is equals to k is 1 by 4 pi epsilon naught into x sigma 2 pi y dy by x square plus y square whole to the power of 3 by 2. So here we observe that 2 cancel, pi cancel, so 2. So now dE is equals to sigma x by 2 epsilon naught, sigma x by 2 epsilon naught, and y dy by x square plus y square whole to the power of 3 by 2. So now we need to calculate electric field a point on the axis. So integration dE is equals to sigma x by 2 epsilon naught integration y dy x square plus y square whole to the power of 3 by 2. The limits over 0 to r. 0 to r. So now here x square plus y square whole power 3 by 2. This is y dy. So now let x square plus y square is equals to some r dash square or r1 square. So now x square plus y square is r1 square. So 2y dy is equals to 2y dy is equals to 2r. We can say r also, 2r dr. So here 2 cancel. Y dy is equals to r dr. Now the y dy is replaced with r dr, and limits also. If y is equals to 0, lower limit is x is equals to r. Y is equals to r. Upper limit is root over x square plus r square. So lower limit is x, upper limit is r, upper limit is lower limit is x, upper limit is x square plus y square root over. So now integration dE is e. Now this is sigma x by 2 epsilon naught. The limits over x to x square plus r square. So y dy is r dr. Y dy is r dr. This is r square whole cube. R square whole power 3 by 2. Square k cancel. So now sigma x by 2 epsilon naught. So now this is dr. This is r cube. Now we can write x root over x square plus y square. The thing is here r, this is r cube, r power minus 2 dr. So now sigma x by 2 epsilon naught, sigma x by 2 epsilon naught, r power minus 1 by minus 1, limits over x to root over x square plus r square, x square plus r square. Now here the thing is minus sigma x by 2 epsilon naught 1 by r, lower limit is x, upper limit is root over x square plus r square. So now we need to calculate electric field. Electric field E is equals to minus sigma x by 2 epsilon naught minus sigma x by 2 epsilon naught. Upper limit is 1 by root over x square plus r square minus 1 by x. The 1 by x is there. The minus send inside. E sigma x by 2 epsilon naught 1 by x minus 1 by root over x square plus r square. So this is E is equals to sigma by 2 epsilon naught into 1 minus x by root over x square plus y square. So this is electric field due to a point on the axis of the surface charged disk. Electric field due to a point on the axis of the surface charged disk. The very important. Suppose if x is equals to 0, at x is equals to 0 means center of the disk, E is equals to sigma by 2 epsilon naught. So this is the most important for JE and even for critical thinking questions in NEET. E is equal to sigma by 2 epsilon naught into 1 minus x by root over x square plus r square. I think I hope that you understand this concept. Thank you, dear students.